In today's video, I wanted to make an announcement that I've been waiting to make, or actually you've been waiting for me to make over the past 2 years. And that is, I finally have the plans ready for you to purchase to build my CNC pickup winder. However, before you take the plunge and purchase the plans, I wanted to make this video to try to inform you about the scope of this project, because this is not a simple bolted together DIY project. I would call this an advanced DIY project, do it yourself, with an emphasis on the yourself. In order to make this machine, you're going to need to be able to fabricate aluminum, plywood, and plastic. You're also going to need to understand the Arduino environment and how that works, because you're going to be flashing an Arduino Uno card with Gerbil 1.1 software. And that's the software which processes the G-code that controls the traversing mechanism. And you're also going to need to understand the basic software that I created that comes with the package that writes the G-code that this machine will use. So as you can see, this isn't just a simple matter of bolt it together, stick a bobbin on it, feed some wire into it, and let it rip. There's a lot more to it. So if you don't feel absolutely confident that you can handle a project like this, I would suggest you maybe reconsider purchasing the plans, especially if you are absolutely dead set on building a CNC winder. Otherwise, you could certainly purchase the plans in an effort to support my YouTube channel, but like I said, if you're thoroughly expecting to be able to build the winder, you need to have those DIY skills to be able to do it. And the reason why I stress that is because I'm a lone wolf. I work completely alone. I build my guitars, I build the tools that I use to make guitars, I shoot all my own videos, I edit them, I post them, I do all my own marketing. I have no employees, which is the way I like it. However, as a result, I can't offer the sort of support you might want when building a project like this. That's why I stress the yourself in the DIY, do-it-yourself concept. You're going to have to be able to not only fabricate and build this machine, but if you run into problems, you'll probably have to solve them yourself. Now, you can try sending me a question through either my e-guitar plans or my Highline Guitars website, but there's a chance I'm not going to be able to answer the question, especially if we start getting really technical, or if you start asking a lot of questions. I just simply don't have the time to do it. What I'm hoping for is that as time passes, perhaps those of you out there who purchase the plans and are able to successfully build the winder and use it, maybe somebody out there will be willing to create a user forum where others can join and follow along and maybe solve some of their issues. It would be sort of a community type of thing. Now, sure, I could probably start a user forum myself, but then that just becomes one more thing I have to manage, and I just don't have the time to do that right now. So I'm hoping that this will become a community project, a community effort. Now, before I explain what you're going to get in the plans package, I need to stress that the dimensions which are featured in the manuals are in inches, not millimeters. Now, there are a couple of dimensions that are described as millimeters, and that's only because some of the components came from countries which use the metric system. But for the most part, the dimensions included in the manuals are in inches. Also, the software program that I wrote, which generates the G-code that runs the machine, requires that you input the dimensions of your bobbin. And those dimensions have to be entered as inches. So just be aware of that. Now, when you purchase this plan package to build the winder, what you're going to be getting is an assembly manual, a user manual, and then the software that I created that writes the G-code that this machine will rely on. And that software is available to run on both the Windows and the Macintosh operating system. The assembly manual includes a step-by-step process of assembling this all the way to completion. It also includes dimensioned drawings for all the different parts, the plywood and the aluminum and the plastic, so that you can cut them yourself. Now, I did all the work on a CNC machine. However, you don't need a CNC machine to do it. If you've got a table saw and a drill press or even a hand drill, you can do that work yourself. You just need to be able to do it very precisely. It also includes a parts list, which describes all the components, all the parts, all the nuts and bolts and aluminum and the different pieces that are used to make this winder. And in many cases, I've included the sources where you can purchase those parts. However, not all of the sources have been provided. For example, I don't offer the source for where you can purchase this mini live center or the traversing mechanism, which is actually a CNC Z-axis slide, or this magnetic wire tensioner. And the reason is these were all purchased on AliExpress, and that means those sources are here today and gone tomorrow. They can change constantly. But in that parts description, in that parts list, I've tried to describe the components in a way that you can easily find them yourself by doing a search. And hopefully that will make it easy for you to gather up all the parts necessary to build it. And even where I have provided links for a lot of the nuts and bolts and bits and pieces, even if you don't purchase from that source, you'll at least have a pretty good idea of what you need to purchase or to assemble this machine, so you can source wherever you want. And I know that having made this here in the United States, I had no issues sourcing any of the components. However, I can't say that's going to be the same case for everybody, no matter where you live in the world. You know, that's just one of those situations where you may run into some supply chain issues or tariffs and all that kind of stuff. That's something I can't really speak to, but I know that building it here in the United States, I didn't have any issues. Now, the user manual is going to help you set up this machine, dial in all the settings and get it ready for use. Then I walk you through the process of winding a bobbin, and that process can be applied to just about any kind of a bobbin that you would wind, whether it's a humbucker, a single coil, P90, bass pickups, whatever. It's all basically the same process. And then there's a troubleshooting section, because as you're learning how to use this winder, you are likely going to encounter some issues with ensuring a consistently wound bobbin, as well as how the magnetic tensioner works and what you need to do to dial it in so that it works correctly. But once you have everything set up and running properly, winding a bobbin is a piece of cake. And you can get it set up, start the winding process, and then walk away. Come back 5 to 10 minutes later and you've got a finished, perfectly wound bobbin. And that will happen every single time. What I will recommend, however, is during this setup and testing phase, you invest in a 5-pound spool of like a 43 gauge magnet wire, because you're going to burn through quite a bit of wire getting everything dialed in just right. And finally, this package is going to include software that I wrote in Python, which creates the G-code that is necessary to run this machine. Now, each time you wind a bobbin, you have to create a new G-code file for that specific bobbin. But it's really super simple. All you have to do is input the inner dimensions of the bobbin's core, along with the number of turns that you intend to put on the coil, and the speed in which you're going to wind the bobbin. And from there you can select either a clockwise or counterclockwise rotation of the bobbin, and you can select from 4 different winding patterns. No scatter, which means a uniform coil, minimal scatter, moderate scatter, or maximum scatter. And that's going to control how the traversing mechanism deposits the wire onto the bobbin. So you can play around with different winding patterns in different directions and achieve different results. So that's really up to you to experiment with that and try those different possibilities. Now, I've written this software so that it can run on either Windows or Macintosh. But again, you're kind of on your own about installing and then using it, but it's pretty simple to use. And I'm thinking about, at some point down the road, I may offer the code for this software so that those of you who understand how to code in Python will be able to maybe play around with tweaking some of the settings, although I would urge extreme caution here. I know from testing the software over the last 2 years that the slightest tweaks can really throw things off. But you can try maybe incorporating some different winding patterns, and you could simply copy the code that I wrote for the different, or one of the patterns that, for example, the maximum scatter, and then change some of the numbers in it to create different winding patterns. But that's a whole different topic. But that's something I'm going to consider down the road. For now, though, you get the software, you can install it on either your Windows computer or your Mac computer, and then you'll have to download another piece of software called Universal G-Code Sender. And I include links for that in the manuals. But then you can download that, install it on your computer, and then what you would do is you would use the G-code writing software to create the G-code, and then you would use Universal G-Code Sender to send it from your computer to the winder to begin the winding process. As I was putting this video together, I was trying to think of some FAQs that would probably come up from viewers. And in an effort to reduce the number of questions that get posted down in the comments, I thought I would try to address as many as I can think of. And one question that might come up is, what kind of bobbins can you wind on this pickup winder? And really, the limitation is the distance between the center of the bobbin plate and the this little sensor here, which senses the number of turns. And that is a little over, it's about 2¼ inches. So any bobbin that's up to 4 inches wide will fit on this winder. So I would imagine that's easily any 6-string guitar, 4-string, 5-string, 6-string bass. But when you start getting into the like 7, 8, 9, 10 strings or beyond, you're going to have to look at the length of the bobbin, and if it exceeds that 4 inches, it probably won't work with this. Now, that doesn't mean you couldn't modify the design. All you would have to do is make a larger diameter circle and then sort of reposition everything. You would have to raise the motor that spins the bobbin a little bit and make this housing a little bit taller. But if you can build one of these, you can probably modify it to suit those kind of needs. So just be aware, as it stands currently, a 4-inch wide bobbin or 4-inch long bobbin, and that's going to be from this end down to this end. This is a 7-string bobbin, and it would fit on here and spin no problem. So yeah, 4 inches, so just be aware of that. Now, the one question I know is going to get asked a lot is, how much does it cost to build a winder like this? And I kept track of my costs as I was building it. However, I had a lot of the bits and pieces, the nuts and bolts and some of the plywood and all that on hand already. So I didn't actually factor all that in. But when it came to purchasing all the main components, the guts for the electronics, the motor for the bobbin winder, this mini lathe live center, the traversing mechanism, the tensioner, all that, the counter, I ended up spending just over $300 purchasing it all new online from sources like eBay, AliExpress. And I think that when it comes to actually making this totally from scratch without having any of the parts or materials, I would suggest you budget for somewhere between $400 and $500, which when you compare that to the cost of a finished turnkey CNC winder, and there really aren't very many of them out there, that's a pretty good price. Okay, another question which I know will probably come up. If I'm using G-code to control the winder, why do I have a counter on here? Well, it's kind of complicated, so bear with me. The G-code really controls the traversing mechanism and how it's depositing wire onto the bobbin. The counter controls the number of turns. So if I want 7,000 turns of wire, I would program that into the counter. And when it reaches 7,000 turns, it would automatically stop. Now in the software that I wrote to control this, to create the G-code, you do input the number of turns, but that isn't going to actually stop the winder at that number of turns. And the reason is the motor that's spinning the bobbin plate is just a standard electric motor, and it's wired into a PWM controller. However, the winder, if you want it to stop on exactly 7,000 turns, you have to use the counter to do it. In order to control everything with just G-code and omit the counter, I would have to use a different type of motor to spin the bobbin. Now you'll see that some of the CNC winders that are out there have what look like stepper motors that spin the bobbin as well as control the traverse. That's true in the case of the traverse. However, to spin a motor, you have to use a special type of servo motor to do it. A typical stepper motor doesn't spin fast enough to achieve the speeds that we need to wind the bobbin. It can only go around 400 to maybe 700 RPM. Any higher than that, it doesn't work. So to spin at faster speeds, which is what most people are going to want, you have to use a servo motor. And unfortunately, when I started building this winder, servo motors are really expensive. It would have dramatically increased the cost of building this winder. So I had a decision to make. Should I, bite the bullet and just make it an expensive winder? The problem with that is there are already CNC winders out there that are built this way that are about the same price. So it kind of takes away from any advantage of building your own winder. Why build it when you can just buy it ready-made? What I did instead was I decided to use just a regular DC electric motor. And then I used the counter to stop it at exactly 7,000 turns or 8,000 or whatever you program into the winder. That same number is what you put into the software that writes the G-code. But the way I created this is I've designed it so that the traversing mechanism will actually continue to run after the motor has stopped, after it was stopped by the counter. So if you programmed in 7,000 turns, the bobbin winding will stop at exactly 7,000 turns, but the traversing mechanism might continue on a little bit longer. And you can either wait for the G-code to finish running, or you can just hit the stop button in Universal G-code Center and stop it. The key here is being able to stop the bobbin winding at a specific number of turns, because that's really what your goal is. But in order to drastically reduce the cost of building this winder, I opted to use that approach. So just be aware of that. Another question that might come up is, even though the software has 4 different winding patterns, is it possible that more winding patterns could be added in the future? Sure, but not from me. For me, 4 winding patterns is plenty to choose from. And I suppose there are going to be folks out there who will think with this type of technology they could create winding patterns that replicate other existing pickups. But I think the effort to try to do that would just be prohibitively complex. So I'm just going to stick with the 4 winding patterns. But if you're the sort of person out there who wants to fiddle around with that, by all means, go for it. And good luck with that. But that's what I'm kind of hoping a community-driven forum might provide, is not only advice on how to build and use this machine, but maybe share some rewritten software with different kinds of patterns, who knows? I think the sky's the limit with those concerns. But the different kinds of patterns is not something I'm going to explore. And the last question I could think of is, it's really not a question that you, the viewer, would ask in an effort to make a decision about whether to buy this. It's really a question that I wanted to answer in order to head off questions that will likely get posted down in the comments section below. And that question is, why didn't I consider another type of operating system for this machine? You know, like a Linux or Raspberry Pi. And I know there's a whole host of different CNC solutions out there that might have been applied to this design. And the reason is I used what I'm experienced with and what I'm comfortable with. And I can tell you, I did a lot of testing, planning, and development of this machine leading up to where it is today. And I think I came up with what would be the best solution for the cost and the capabilities that I needed. So I hope that answers that question. Okay, enough blabbing. Where can you purchase the plans? Well, it's easy. You can visit my eGuitar Plans website. Scroll through all the plans. It'll be down there among the tools that I offer plans to build. Or you can visit my YouTube merch store, which is displayed down below this description. If you can't see that store, there's a link in the description as well. So hopefully you will be encouraged to take the plunge and build this winder, and I hope that you will have as much success with it as I've had. It is a great and fun machine to use, and it can really expand what's possible with dialing in and shaping the tone of the electric guitars that you're also building. Or you could even start a business making pickups, who knows. At any rate, until the next episode, as always, take care, stay safe, be sure to give this video a thumbs up and subscribe and all that good stuff, and I'll see you soon.